Hi, wonderful people. We are looking today at how free fall is connected to heat energy, right? Yeah. So a free falling body. Let's consider a body. Let's say this is the ground, for example. Let me use a different color, right? Let's say this is the ground, right? Ground. And an object is falling at a certain height above the ground. Let's say this height, and this body possesses mass. Okay, mass. So it's falling through this height. It's falling. All right. We know that, let's say, the height above the ground is, let's say, h. As it falls through, an assumption we want to make is that before we look at assumption, we know that the potential energy possessed by the body is the energy by virtue of the body's position, right? So if you want to look at the potential energy, then we know from our basic mathematics, basic science, that the potential energy is given by the mass times the acceleration due to gravity times the height above the ground. Now, we are making a very powerful assumption here. We are assuming that there is no other energy. Before, we are saying that before the body, we know that it will pass through various forms of energy, right? But assuming that all before the body hits the ground, all energy is converted to heat. If all energy is converted to heat, then this potential energy we are talking about should be equal to the heat energy. That is an assumption we are making. So if say there is, if take it like there is no other, all the other forms of energy, being kinetic, being whatever, are all converted to heat. If they are all converted to heat, then we can now write that the potential energy is equal to the heat energy. And this heat energy we know is Q. All right. And we've learned from specific heat capacity that C equals the amount of heat energy M times theta, right? So our K will be what? MC theta. So in terms of specific heat capacity, if we are saying that the energy or forms of energy is converted to heat, then we are calling this Q as MC theta, like what I did here. So I'm fixing it here, as you can see. Now, because we are dealing with just one body, that is our body falling, the mass is the same mass we are dealing with. So the masses will go, and we will be left with this powerful equation. So take note of this powerful equation. Meaning that when a body falls through a certain falls at a certain height above the ground, and assuming all the energy is converted to heat, then we can ignore the masses and look at the height. We can look at the change in temperature, and we can look at the specific heat capacity. Take note. Now, what about from this reference equation? This is our reference equation. This star is our reference equation. So, assuming I don't want to express this one in terms of specific heat capacity, but I want to express it in terms of heat capacity. It's also there. If I want to link it with heat capacity, then we know that heat capacity is Q over what? Theta. Then what will be my heat energy? It's going to be capital C theta. And the potential energy is also going to give me this in terms of heat capacity. Don't forget the theta is changing temperature. Let's look at a nice question on this. A waterfall, 50.0 meters high. A waterfall 50.0 meter high has temperature difference at the bottom, at the top and bottom, 0.8 degrees Celsius. Calculate the specific heat capacity of water, stating any assumption made. Whoa. So they want us to state an assumption we made, and they want us to also find the specific heat capacity. Let's put down our information. So we are given the height. We have been given the temperature difference. The temperature difference is the change in temperature, okay? 0.8. And we are looking for specific heat capacity. Which is our small letter C. Now, they have given us J as 10 meters per second squared. So what do we do? We make use of the equation. The potential energy equals what? The heat energy. Assuming all, so the assumption they want us to make is what we are assuming: all energy is converted to heat, right? So then what do? We can now say mgh equals what? Because we were given specific heat capacity, we will say what? Mc theta. So we say gh equals c what? Theta. Hope you are getting it. So this is the equation we are going to use. Let me call this 1. We are looking for C. It is mathematics, so you can do it whatever. You can substitute in the values and make theta the subject, and make C the subject, or you can make C the subject before. All right. So it's not a fixed approach you are supposed to use. So I can say from equation 1, I can say that gh over theta equals what? C. Now that is what we are looking at. 10 times 50 over 0.8. Okay. So this one is going to give me 500 over 0.8. And you can use calculator. You can work. I don't want to waste time, so let me use calculator. So 500 divided by 0.8, I'll get 625. Joule per kilogram per degree Celsius is equal to C, right? Therefore, the specific heat capacity 625 joule per kilogram per degree Celsius. So that is that for this question. Hope you enjoyed it. This was the question. Went through this process, the assumption we made, and we are landing at this. All right, I have one nice question here. And I want you to try it. When I tried, I had this. See if you will get the same answer. And let me hear from you. Thank you. See you again.